Imagine a world where buildings repair themselves, where roads mend their cracks without human intervention. It sounds like science fiction, but it's not. It's the world of self-healing concrete. Concrete, the most used construction material in the world, is incredibly strong, but it comes with a hidden weakness: cracking. Over time, all concrete cracks. This is due to natural forces like temperature changes, weather conditions, or even the very settling of the structure itself. These small cracks let water in, which can lead to rusting of the steel reinforcement inside, and over time, it weakens the structure, causing huge maintenance issues. The cost of repair is astronomical. In fact, in the United States alone, it's estimated that over $100 billion is spent each year on repairing concrete infrastructure. But what if concrete could fix itself? Self-healing concrete is designed to do just that. Imagine a crack forms, but instead of becoming an entry point for water, it simply seals up, as if the concrete were alive. This is the magic of self-healing concrete, a material that mimics living organisms, capable of self-repair. There are several fascinating methods scientists use to make concrete self-heal. The most well-known involves bacteria. Yes, bacteria. Specifically, a type called bacillus, which can survive in the harsh, dry environment of concrete for decades. Here's how it works. These bacteria are mixed into the concrete, along with calcium lactate, their food source. When a crack forms and water seeps in, the bacteria spring into action. They feed on the calcium lactate and produce limestone as a byproduct. This limestone fills the crack, effectively sealing it. Think of it like tiny, invisible workers, microbial masons, filling in the gaps when damage occurs. This is inspired by biomimicry, where technology tries to emulate the natural abilities of living organisms to solve human challenges. Bacteria aren't the only way. Another method involves embedding microcapsules, filled with healing agents, into the concrete. When a crack occurs, the microcapsules break open, releasing substances like epoxy that harden and close the crack. Yet another innovation uses a type of polymer, which reacts with CO2 in the air to create a sealing material. Each method has its own unique way of dealing with damage, but they all share the same goal: making our infrastructure smarter, more durable, and ultimately, more sustainable. Imagine if our highways could heal themselves. No more lane closures for road repairs. No more costly bridge maintenance or dangerous building failures. Self-healing concrete could transform our cities into something almost alive, adaptive, resilient, and sustainable. Research shows that structures built with self-healing concrete could see their lifespan extended by decades, even by 200 years in some cases. This could potentially save trillions of dollars globally. One incredible example is in the Netherlands, a country known for its innovative approach to engineering. They have built several pedestrian and bike paths using self-healing concrete, and the results are promising: reduced maintenance costs and a much longer-lasting surface. Similarly, in South Korea, self-healing concrete is being tested in major infrastructure projects to help deal with the extreme weather changes that often damage traditional materials. There's also a significant environmental benefit. Concrete production is responsible for about 8% of the world's CO2 emissions. By extending the lifespan of concrete structures and reducing the need for repairs, self-healing concrete can reduce the overall demand for new concrete production, thus lowering emissions. But like any new technology, self-healing concrete faces challenges. The costs are currently higher compared to traditional concrete, and large-scale implementation has been slow. However, as research continues, the cost is expected to drop, and we may see it become a standard material for construction in the future. Imagine buildings, bridges, and roads built not just to be strong, but to be alive, to heal and adapt to the environment around them. That's the promise of self-healing concrete. It's a future where our infrastructure isn't just something we build and forget, but something that actively cares for itself. So, next time you drive over a newly paved road or see the construction of a massive skyscraper, think about the future, one where the concrete itself is alive, working silently to repair and protect the structures we depend on. The promise of self-healing concrete is not just one of convenience or cost savings, it's the promise of a world that adapts, evolves, and becomes